Waalaikumsalam, sir.
Right. Please on your camera. Please do on your camera. Uh, please on your camera. Okay, before we start, we recite Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir-Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Right, we still in chapter 3, chapter polynomials and rational functions. We already finished part of the polynomials. Then now we move to the parts of rational functions. So we go to the continue of the partial fractions. Find the partial fractions decomposition of this rational function, these rational functions. We want to find the partial fractions of these rational functions. So first of all, what we have to do when we want to find to solve the problems of decompositions of partial fractions. First step, what we have to do. First step.
Check whether improper or proper.
We need to check our rational function proper or improper. If you look at our case, our rational function proper or improper?
That function is proper, sir.
Proper. Therefore, we no need to do long divisions because it is proper. So we go straight. So the next step is to what? The next step.
Factorize.
You factorize denominator. So how to factorize this? How to factorize this? X cubed plus 4x squared plus 4x. How do we factorize it? How do we factorize this?
We can take firstly we can take the x out first.
So make x as common factor. So let's say this. Okay. X cubed plus 4x squared plus 4x. So we take x out. So x multiplied by what? We want to produce x cubed. So x must be multiplied by
X squared
x squared. And then plus
for x and plus 4.
4x and plus 4. So this part remain x. This part is quadratic. We can factorize to be x 2 plus plus. So it is equal to x plus 2. X plus 2 appear 2 times. X plus 2 square. How do we get x times x plus 2 square? Now, when we look at these factors, these two factors, what do we get? One factor is how many factors we have?
3, sir.
3 factors. But when we talk about type of factor, how many type of factors we have?
2 type.
2 types only. This one we call
Linear.
linear factors, and this part is
We repeat
Repeated
quadratic.
linear factor.
not quadratic. This one
Repeated linear.
repeated linear. Still linear, but repeat. Repeated linear. We repeat. The linear, repeat. So, which rules we need to apply?
Rule A and Rule B, sir.
Rule A and Rule B. Rule A is A over X plus Rule B. Rule B is, if you look back at the Rule B, how to get the Rule B? Rule B,
B over x plus 2.
X plus 2 and plus with
C over x plus 2 square.
okay. Why we stop at x plus 2 square?
Because the power is 2.
Because our factor and the highest is power is 2. Now we want to make same denominator. So A must be multiplied by x plus 2 square. Because the cancellations later, we'll get A over x back. B must be multiplied by in order to get x plus 2 square. So x plus 2 must be multiplied by what? Now we want to produce x plus 2 square. X plus 2 square. So x plus 2 must be multiplied by
X plus 2 square and x.
no, we already have x plus 2. We multiply by what?
X.
No, x. Okay, you look back here. X. We want to get x plus 2. We already have x, so we need to multiply only with x plus 2 square. Right, x here. Must be multiplied by what? To get this. X must be multiplied by what? To get this.
X plus 2 square.
That's why A must be multiplied by x plus 2 square. B, x plus 2 must be multiplied by what to get this?
X plus 2 x.
X plus 2x. That's why B multiplied by x plus 2x. Then x plus 2 square must be multiplied by what to get this?
X.
X. That's why C must be multiplied by x only. And now expansions. Expansions. So we get A plus B. This is the coefficient of x squared. We group together. Coefficients of x, we group them together. Then coefficients of no x or x to the power of 0, we group together. And then we compare. 2 same as A plus B. 2 is equal to with A plus B. I forget about this. Yeah. 2 is A plus B. 5 is for A plus 2B plus C. And 8 is for A. 8 is for A. Comparison. We use the method of comparison. Yeah, we compare. So what do we get? What do we get? A plus B equal to what?
2.
2 for A plus 2B plus C equal to
5.
5. For A equal to
8.
8. Then we get all those values of A and B, A, B, and C using simultaneous equations. What do you get the value of A?
2.
B?
0.
C?
Negative 3.
That's 3. So you obtain all the values of A, B, and minus 3. Right. Now we can rewrite that to x squared plus 5x plus 8 over x cubed plus 4x squared plus 4x equal to a is 2. 2 over x. We substitute a with 2. Plus b is 0. 0 over x plus 2. Plus c is minus 3. Minus 3 over x plus 2 square. Two over x plus 0 over x plus 2 plus minus 2 over x plus 2 square remember that 0 plus x over 2 is 0. Therefore, we can rewrite this as 2 over x plus minus 3 over x plus 2 square. Since b is 0, so everything's in this term becomes 0. When 0 appear in our numerator, we will get 0. Only when 0 appear in denominator, make it undefined. In numerator can, but it make that everything's 0 for this part. Only for this part. For another part, do not know. We cannot have 0 because they have the value. A has a value, C has a value. You get it? So for this case of partial fractions, we can skip step number 1. Why we can skip? Because rational function give to us already proper. Therefore, we no need to do partial. We don't need to do step of long divisions. Step of long divisions only for the case where our rational function is improper. The process to make it proper. Any questions?
Sir,
Yes.
if the decomposition
Uh,
has a
cannot hear you. Cannot hear you.
if the composition have has a denominator x plus 2 cube, so the factor must be until x plus 2 the power of 3 ah.
You mean here if x plus 2 cube? You mean?
Yes.
So until x plus 2, we have one more plus d over x plus 2 cube.
Oh. Thank you,
We
sir.
have one more.
Sir,
Yes.
can we see the calculation at the bottom of the whiteboard? Because we cannot see it.
Can
Thank
you
you.
see?
Can.
Okay. Find the partial fraction decomposition of 7x cubed minus 11x squared plus x minus 2 over x minus 2 x squared plus 1. Now, we need to determine whether this is proper or improper fraction. Proper or improper?
So I think we have did this question.
Eh?
I think we have did this question before.
We have did this question before.
Yes.
Yes, sir. Yes.
Okay. Minus x square plus 5x minus 19 over x square plus 4 x minus 1 proper or improper?
Improper.
Proper?
Improper.
Improper? Why it is improper? Why you say it is improper? If you say it is improper,
Because the power of x.
the power of x,
The denominator and numerator has the same power of x, which is squared.
but here we also have x minus 1. Right. How can you say it's the same? Here in denominator, we still have x minus 1, meaning that the power of x is what? The power of x is what?
3.
3.
Uh,
Remember the index. So the power of x is 3 here in our denominator. In numerator, the power of x is 2. Therefore, this is proper. So, proper, which means that we do not have to use long divisions. We go to the next one. We go to step number 2. Step number 2 is what? What is step number 2?
Factorize.
Factorize. Denominator. But our denominator already in factored form. See, our rational function is become this. Minus x squared plus 5x minus 19 over x minus 1 x squared plus 4. But x squared plus 4, is that this is irreducible? When we say factor, we say this is linear. We can say that. It's linear. Correct.
correct.
Yes.
This one, this one,
Quadratic.
quadratic, but when we talk about quadratic, we have to make sure it is irreducible quadratic. If this type of quadratic which is irreducible, irreducible meaning that we cannot reduce any longer. Can we reduce it?
No.
Can,
No, sir.
can.
Can je. Can sir.
Can
Can.
X
to get
was
what?
to
No, I think no.
No. No, sir.
X squared plus 4, we cannot reduce any longer. So this is irreducible quadratic. So for the first one, which rule we apply? For the
Linear.
first linear,
Linear.
which is
A
A over
X minus 1.
X minus 1 plus which rules we apply now?
Irreducible quadratic.
Irreducible quadratic. Plus
Bx plus C
Bx plus C
over X squared plus 4.
squared plus 4. So minus x squared plus 5x minus 19 over x minus 1, x squared plus 4. And now we want to make same denominator with this denominator. So a must be multiplied by
X squared plus 4.
x squared plus 4. Bx plus c must be multiplied by
X minus 1.
x minus 1. So minus x squared plus 5x minus 19 equal to a x squared plus for a plus b x squared minus bx plus cx minus c. Expansions. A times x squared plus 4. Bx times x, bx times minus 1, cx minus c. Any problems? Any problems up till here? Question? Minus x squared plus 5x minus 19. We group together coefficient of x squared. What is the coefficient of x squared?
A plus B.
coefficient of x. Coefficient of x.
Negative B plus C.
And for A minus C. So we compare. A plus B equal to -1. Minus B plus C equal to 5. For A minus C equal to -19. What you get for A, B, and C?
A equal to -3, B equal to 2, C equal to 7.
Then substitute back. We substitute back. Minus x square plus 5x minus 19, x minus 1, x square plus 4, minus 3 over x minus 1 plus 2x plus 7 over x square plus 4. Okay. We substitute all the values of A, B, and C. You get that? Any question?
Sir, can we
Yeah.
see the lower part?
Huh?
The
See?
lower part of the pot.
Sorry?
We cannot see the lower part.
Lower. Okay. Can you see now?
Yes. Yes.
Sorry about that. Any question? Any questions?
No, sir.
Okay. Another function. Okay. Another rational function. First of all, determine whether the function is rational, proper or improper.
Proper.
Proper. So we need to no need to use long divisions. So for x minus 3 over x plus 4, x square plus 3. So step number two, factor denominator. Our denominator already in factored form. This one, which factor?
Linear.
Linear. This one,
Quadratic.
quadratic, which is irreducible. Remember that rule number C apply for irreducible quadratic. Quadratic which is reducible cannot. We have to reduce it. So it is irreducible quadratic. It is equal to what? Equal to what?
A over x plus 4
A over x plus 4
plus
plus
bx plus c
bx plus c over
x square plus
X squared plus
x
B.
square plus 3. For x minus 3, x plus 4 x square plus 3. You want to make same denominator. A must be multiplied by
X square plus 3.
x square plus 3. Bx plus c must be multiplied by
X plus 4.
x plus 4. So we have for x minus 3 equal to a what?
X square plus 3A.
X square plus 3a plus
bx
bx square.
plus bx square plus 4b
For bx
plus cx
plus cx
plus
plus
4c.
4c. So 4x minus 3 equal to a and b be grouped together as coefficients of x square, coefficients of x,
For B plus C.
for b plus c, and another one 3a plus 4c. Then we compare. A plus b is equal to 0 because we don't have x squared. For b plus c equal to 4. And 3a plus 4c equal to minus 3. Search for A, B, and C.
A equal minus 5.
A minus 1.
Minus 5, sir.
Minus 5. B,
0.
0. C,
4.
4. Is that you get the value? Same value?
My A is -1, sir.
A is -1.
B 1,
B1,
C 0.
C0. This one is correct. And A is supposed to get -1, B is 1, and C is 0. And then you substitute back. You substitute back. So for x -3 over x plus 4, x squared plus 3 equal to A. A equal to -1, right? X plus 4 plus B is 1 times x over, because C is 0, x over x squared plus 3. You're supposed to get the value of A is -1, B is 1, and C is 0. We do simultaneous equation, that simultaneous equation. Right. So the important is to know the type of our factor. Which type? Either type number 1, or linear, or maybe repeated linear, or maybe irreducible quadratic, or maybe repeated irreducible quadratic. Any questions?
Sir,
Yes.
how do we know that it is reducible or irreducible?
Irreducible is something that you cannot reduce. You try to make that our quadratic x square plus 3. Can you reduce it? X square plus 3. You cannot reduce. You cannot factor more. So that it's irreducible. Not every quadratic that irreducible. Some quadratic reducible. For example, x square minus 1. This is quadratic but reducible because we can write as x plus 1, x minus 1. We can reduce. But for the case of x squared plus 3, for our case of x squared plus 3, are no more reducible. Cannot be reduced. That's how we know that it's irreducible. So when you look at the quadratic, you have to make sure that it is irreducible. Some, yes, reducible. We can reduce more. Some irreducible.
Thank you, sir.
Okay. Right. With that, we finish off chapter 3. Questions for this chapter will be for quiz 2 next week on 14th of September, on 14th of October, night time. And also question for this chapter will be on end of semester examination as well. Since end of semester examination will cover everything. So for the next lesson, we start off new chapter, chapter 4. So in the meantime, you can look at what we cover for chapter 3. Right. So with that, I close and stop sessions today. I close these sessions with Tasbih Kifarah and Surah Al-Asr.
Thank you, sir.
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 Thank you, sir.